Hello my friends, welcome to this new practical tutorial, and here we go for the implementation of our new data preprocessing tool, feature scaling. Alright, so let's add a new code cell, but before, let me just remind you the two types of feature scaling. The first one is normalization, in which you subtract each feature value by the minimum of your feature divided by the difference between the maximum and the minimum of your feature. And then the second type of feature scaling is standardization, where you subtract each of your features by the average of your feature divided by the standard deviation. And also, before we start, I just want to point out something very important. You notice, by looking at the dataset, we will have a look at it again. Here it is. You notice that in the dataset, all the variables, all the independent variables have their values between 1 and 10. So we could think that the dataset is already scaled. But no, even if we have all our independent variables within the same scale, between 1 and 10, that's not enough for our logistic regression model to do its training. You will have much better results. You can try in the end to rerun this implementation without feature scaling. You will have much better results with standardization applied to your independent variables. So let's not fall into this trap that if we have some independent variables under the same scale between 1 and 10, that we would not apply feature scaling. We always have to apply feature scaling whenever we deal with a gradient descent based algorithm like logistic regression or neural network based algorithms, which we will see in level 3. Alright, so I just wanted to stress this, and now let's implement feature scaling. Alright, so I have a slight preference for standardization. That's just due to my experience. In my experience, I always tried both normalization and standardization, and I had slightly better results with standardization. So that's my little favorite, and that's what I'm going to show you in this tutorial. And of course, we're going to do this efficiently with the help of scikit-learn and classes. And so the first thing we're going to do is import a new class from the preprocessing module of scikit-learn, which is called standard scaler. And so we're going to start from, our scikit-learn library, which has a name as klearn. Then from the scikit-learn library, we're going to access the preprocessing, here we go, module by scikit-learn. And from this module, we're going to import, this new class, which is called standard scaler. There we go, class, standard scaler. And the instance that we're going to create from this class will be exactly the scaler that will apply standardization to our training set, right? Not to our data set. Remember what I told you? Feature scaling must be applied after the split of the data set into the training set and the test set, because in the data set you have your test set, therefore new observations on which the model won't be trained, and therefore it absolutely does not make sense to do the standardization scaling based on the average and standard deviations of your features in the whole data set. You have to compute those in the training set. Alright, so let's do this. Now that we have our class, we can create an instance of this class, which we're going to call SC, and then you know how to create an instance of a class. We simply need to call the class itself, standard scaler, there we go, and then we add some parentheses, and we don't have to input anything inside the parentheses. Alright, next step, now that we have our object, what do you think we're gonna do with this object? Well, remember that a class contains some methods, which can perform some actions, and of course you imagine that one of those actions is the one that will perform the scaling. Alright, but in order to perform the scaling, the scalar object will have to do something particularly first. What is that? Well, it will have to compute the average and the standard deviation of your features, because that's what we want to scale, and in standardization, we subtract each of the feature values by the average of the feature, and we divide it by the standard deviation of the feature. And so, before we do the transformation, before we do the scaling, we have to compute those values for each of the features. But good news, there is actually a method that does both at the same time. It will compute the average and the standard deviation of your feature, and then proceed to the standardization of your feature based on those calculations. And that method is called fit_transform. And you could also do it in 2 steps. You could use first the fit method that will get those values as the average and the standard deviation, and then use the transform method to perform the scaling. But let's do it in 1 step. Let's do it efficiently by using the fit transform method. Alright, so let's call our object first as C. Then from this object, we're going to call this fit_transform, here we go, method. And what do you think this method takes as input? Well, of course, it takes the array of independent variables you want to scale. And since now we have to scale the array of independent variables in the training set, right? Because we are preparing this for the next step when training the model. Well, of course, what we have to input here is x_train, which is exactly the array of independent variables in the training set, which must be scaled, which must be standardized so that we get an amazing training of our logistic regression model and therefore in the end some great performance. Okay, so there you go. But then be careful, this fit transform method actually returns something, and of course what it returns is the new array of scaled independent variables. And we can actually call this again xtrain. And why is that? That's because the old version of xtrain, the non-scaled independent variables, won't be useful to us anymore. We won't need this array of independent variables with their original values. We will only need this new array of independent variables in the training set with the scaled value. So that's why we can just update the value of our array of independent variables in the training set, xtrain. Okay? And congratulations, my friends. That's it for feature scaling. That's the only thing you have to do to prepare your array of independent variables in the training set for the training, which we will do in 2 tutorials. And so now we're going to run this cell to make sure our independent variables in the training set are scaled. And now they are, so we can move on to part 2, building and training the model. I'll look forward to building this logistic regression model with you in the next tutorial. And until then, enjoy machine learning.